In this video, we're going to talk a little bit more about gravimetric analysis. And if you haven't already watched the How Much Is There video, you should watch that first. In the gravimetric analysis, we're going to analyze for a particular analyte, say chloride, in a sodium chloride solution, for instance. By reacting that chloride with something that produces a solid product. And so we might have silver nitrate as a reagent because silver nitrate produces silver plus in solution, and we know that silver plus reacts with chloride minus to form a solid silver chloride precipitate. So if I take my analyte solution, add it to a beaker, and then add enough silver nitrate to that same beaker until no more solid precipitates, until I've precipitated all of the solid that I can possibly precipitate. So I keep adding silver nitrate until no more solid appears. Then I know that I have used up all the chloride in the original solution. And if I've used up all that chloride, it must all be contained in this silver chloride precipitate that's at the bottom of the beaker. And so now I just need to take and get that solid away from the rest of the solution. So I filter out the solid, I isolate it, I make sure it's good and dry so it doesn't contain any water, and I weigh it. And if I know the mass of this silver chloride, then I know the number of moles of silver chloride. And if I know the number of moles of silver chloride, I know the number of moles of chlorine. And all of those chlorines came from this original analyte, and so I now know the number of moles of chlorine that were originally contained in this solution. And that's the basics of gravimetric analysis. Let's see how this gravimetric analysis works by solving the following problem. A 0.423 gram mass of a compound containing bromide. So we're starting with a compound, a solid compound that contains bromide. So there's some counter ion, some metal counter ion, some number of metal counter ions, and we know that it has bromine, but we don't know how many bromines, and we don't know what the counter ion is. So we have this unknown compound, but we know it has bromide in it. And we're going to take that and we're going to dissolve it into water. So we take this and we put it into a beaker with water. And when we do that, we've got bromide minus ions floating around and metal cations floating around. We don't really know what the charge on those metal cations is, so we'll just call it N+. So this solution now contains bromide ions and some counter ion that we don't really care about at this moment. We're going to take that and we're going to treat it by adding silver nitrate, aqueous silver nitrate. So to this, we are going to add silver nitrate, and the silver nitrate aqueous consists of silver plus, because it's an ionic compound, and nitrate minus ions in solution. And when we do that, we know that we can write a chemical reaction between the bromide and the silver plus. So there's our known chemical reaction that we're going to use to do this analysis, and it's going to form silver bromide solid. And so when we do this, we're going to end up with silver bromide solid down here at the bottom of the beaker. So this is going to be silver bromide solid at the bottom of the beaker that gets formed from the bromine in the original compound and the silver plus that we've added from the silver nitrate solution. So then we isolate this product and we weigh it, and we find that it in fact has a mass of 0.3851 grams. Okay, so the question is, what is the mass percent of bromide in the original compound? So what I really want to know is the mass of bromine, so the mass percent of bromine is equal to the mass of bromine in the original compound divided by the total mass of the compound. And I know the total mass of the compound because I'm told it was 0.4230. So I divide the mass of bromine, once I get it, by 0.4230 grams, and that will give me the mass percent of bromine. So now my job boils down to finding the mass of bromine that I have based on knowing the mass of silver bromide that I have. So I know the molar mass of silver bromide because I know its chemical formula, and so the molar mass of silver bromide is 187.77 grams per mole. And if I know that, then I can find the number of moles of silver bromide because the mass divided by the molar mass will give me the number of moles. And so 0.3851 grams of silver bromide divided by its molar mass, 187.77 grams per mole, tells me that I have 2.05 times 10 to the minus 3 moles of silver bromide. And since I know that every silver bromide contains one bromine, I know that I also have 2.05 times 10 to the minus 3 moles of bromide. And now I just need to use the molar mass of bromine to find the mass of bromine that is equivalent to that number of moles. So I take the number of moles times the molar mass, so 2.05 times 10 to the minus 3 moles of bromine times 79.904 grams per mole of bromine tells me that I have a mass of bromine that is equal to 0.1630 grams of bromine. And now I can just plug my number of grams of bromine into my formula for the mass percent of bromine. And so my mass percent of bromine is going to be 0.1630 grams divided by 0.4230 grams times 100% to change it into percentages. And I find that I have 38.74% bromine in my compound that I started with.